To the Math by Matthew virtual homework help this Monday, October 10th at 7 p.m. We are coming to you live from Tucson, Arizona, and this class is all about you, the student. We will be answering as many of your questions as possible. To get your questions answered, Paul will be communicating with you directly through the Zoom chat. He will get some preliminary information from you and then get you queued up to get your question directly answered by me, Matthew. Let's start like we always do by taking a look at the question of the day. This question offers daily practice and is a tune-up for college entrance exams like the SAT and ACT. This question and full solution can be found at mathbymatthew.com. A new question is posted there every day. Let's start by taking a look at today's question. Today's question says, which of the following is a true statement about the ordered pair -4, 3? The system is given, and we assume that there's something about this point that may be true or not true, depending on the question that's asked. Let's start by just substituting those values into the first equation. I'm putting -4 in for x and 3 in for y. This reduces to -28 plus 21. And when we simplify the left-hand side, it becomes -7 equals -7. This is a true statement. This means that it is a ordered pair on the line indicated by the first equation. Let's try it in the second equation. Again, I'm substituting in -4 for x and 3 for y. Simplifying, we find that 24 minus 27 is -3, which equals -3. Both of these are true. So we know that this point represents the intersection of the two lines, and therefore it must be a solution to both equations. Therefore, the correct answer is letter A. The ordered pair is a solution to both equations. As a reminder, to find the question of the day, please visit our website, mathbymatthew.com. Our website has the question of the day under the Question of the Day tab. From there, you will see a new question that is posted every day. If you visited our website in the past, the solution used to be part of the PDF that is on the screen. We're now simply asking for an email address to get that solution sent directly to you. We appreciate you providing your email address, and we promise not to give it out to anyone else. We simply want to know who's coming and visiting our website. Again, a new question is posted every day. Let's look at that question of the day from another angle. What I mean by that is some of the solutions to this question indicate that it is possible that the solution, the ordered pair, could be a solution to one line but not the other. So let's do a little bit of review about lines and systems. The fact that we have two lines indicates that in the first scenario, two lines can absolutely intersect in an ordered pair. That's what we saw in this question of the day. This has one solution. It's also possible for two lines to be parallel. This has no solution. And it's even possible for two lines, especially when they're presented in standard form, which is the way that they were presented in the question of the day, for these lines to actually be the same line. These are considered to have infinite solutions. And there are other words that we can use to express the solution to the system. Let's take a look at that question of the day one more time, but let's just look at the equation that's given first. The equation is 7x plus 7y equals -7. Now, I can, for example, solve this for y, but I don't need to for what we're going to do next. I'm going to give you an x value. Let's just say that x is 1, and let's find the value of y. The value of x is substituted into the equation. We don't know the value of y, and that means that we can solve for y. I'm going to give you a moment just to try and solve for that on your own. All right, if you're still with us, you've tried to solve this. I'm going to go ahead and solve it here. 7 times 1 is 7, plus 7y equals -7. I'm going to subtract 7 from both sides. To be very clear here, when you subtract 7 from a negative number, it does not become 0. It becomes more negative, meaning that it's even further from 0. This is -14. Divide by sides by 7, and we find that y equals -2. So we're going to put that result up here. So what we have here is an ordered pair that fits on the first line. We know that 1 comma -2, we know that this ordered pair here is a solution to the first equation. Now let's try it in the second equation. To do that, I'm going to write the second equation over here to the right, -6x minus 9y equals -3. And I'm going to substitute these values. X is 1, y is -2, and I'm going to simplify the left-hand side. -6 plus 18, and I'm going to reduce the left-hand side. It becomes 12 equals -3. This is not true, or false. Since it's false, we know that the ordered pair that I just provided for you, 1 comma -2, if that were given here, let's just say this was, instead of this was 1 comma -2, what would the correct answer be? Well, we know it's a solution to the first equation, but not the second. So it is not a solution to the second equation. So these are always difficult to answer because there's a negative involved in it. It even gets even more difficult when it says which of the following is false about this. So what I like to do is I actually like to read this as if it is the word not is missing altogether. And I read it to myself and I say, okay, the ordered pair is a solution to the second equation. Is that true? No, the ordered pair 1 comma -2 is not a solution to the second equation. Okay, which means that in this case, since it's asking, if I eliminate that word not, if it is a solution to the second equation, that would make this true. But since it's false, the not changes that altogether. The ordered pair is not a solution to the second equation. That's definitely true when we plug in this value. The ordered pair is a solution to both equations. Is it a solution to both equations? No, we know it's only a solution to the first equation. So that is false, but when we add the not in there, that changes to also being true. The ordered pair is a solution to neither equation. Well, we already know that it is a solution to the first equation, so this is false. Again, everything I just said is about this ordered pair, not the one that has been given in the question. Let me quickly let you know about other products and services offered by Matthew, because the virtual homework help is a great opportunity to get a quick question answered, something that maybe you found on your homework to be difficult to understand and you just want to get it done before the deadline, or maybe there was a concept from class that just wasn't super clear. Well, this is a great opportunity for the virtual homework help because we are here to answer your questions for you, the student. We ask that you connect with Paul. He's going to work with you through the Zoom chat to get your questions queued up to be answered by me. If you're looking for more direct one-on-one help, please consider the Meet with Matthew private tutoring. This is available by going to our website, and we have three options. The first is the traditional one-on-one lesson. The second option is on-demand tutoring. This is a real short session. And the third is how you found us today. It's the virtual homework help, which we do every Monday, and it is absolutely free. And we definitely appreciate you joining us today. If you do have a question, definitely get it to us. You can connect with us directly here or send it by email to learning@mathbymatthew.com. And we will get it queued up as quickly as we can to be answered for you here today. Let's take a look and see if we've got any questions that have come in. Doesn't look like we've got anything new or anyone on hold. So at this point, I just want to thank you for taking the time to check out the virtual homework help. We look forward to helping you again next Monday at this time. And we're always here to help as needed, and we appreciate your time today. Thank you very much, everyone, and have a great night.